Are you ready to take your search game to next level? AWS OpenSearch got you covered. It is an ultimate tool for getting insights into your data. So what is AWS OpenSearch? AWS OpenSearch is a highly scalable open source platform for search and analytics. It has a broad range of use cases. Data can be ingested from various sources and it can be quickly searched, analyzed, and visualized. Prominent use cases of OpenSearch include the application monitoring, anomaly detection, and website search. OpenSearch and OpenSearch dashboard were originally derived from Elasticsearch version 7.10.2 and Kibana. So the software is started in 2021 as a fork of Elasticsearch and Kibana, with the development led by Amazon Web Services. The goal is to make OpenSearch a genuine community-driven application with several different maintainers. It has a set of plugins that further extends the capability of OpenSearch. So why we should use AWS OpenSearch? So the first point is because of its lightning fast and real-time text search. Because OpenSearch provides the ability to search through the semi-structured and unstructured data very efficiently. So let's go through some of its use cases. So the first one is e-commerce. It can be used to search through the products on the e-commerce website and user can get the result very quickly. The second one is social media. User searching for other user profiles, other business pages, groups and posts. So it can be used in that. The third one is content management system. So it can be used to search through large volume of text-based content such as article, blogs and news stories. So the fourth one is data analysis. So it can be used to analyze and search large data set in real time, allowing users to uncover valuable insights and make data driven decisions. The fifth one is customer support. So it can be used through to search through the support tickets and inquiries and making it easier for customer support agents to find the information they need to resolve the customer issues very quickly. The sixth one is enterprise search. So it provides a very fast and accurate search functionality for enterprise level applications such as search engine, document management system, knowledge base, and the seventh one is medical research. So it can be used to search through large volume of scientific literature, helping researchers to uncover new insights and trends in the field. So moving forward to the next point, log analytics and machine learning driven anomaly detection. So we can log insights and observe and analyze logs generated by website, application, and systems. So then we can use that logs and metrics and we can apply machine learning different models on that and then we can detect different anomalies and different problems. So use cases include performance and security monitoring, auditing, alerting, and threat detection. Moving forward, what is the data lifecycle of OpenSearch? So we have the following states in AWS OpenSearch, but it is not mandatory that the data goes through all of these states. You can consider these states as different data clusters. So in the hot state, this is the state where the data is being actively written to and data is stored on a very fast and very efficient storage. And then once the cluster is full, we have like the cluster size of, for instance, 40 GB. So once the 40 GB data is full in that cluster, it will move to a warm state. In the warm state, we are no longer writing the data to that cluster, but we are still fetching the data from that warm state cluster. And then there is a new cluster for hot state in which the data is being written to. And then eventually, the warm state data, it stays with us for like for instance 6 months, and then we are not actively querying that data. Then we move that data to cold state. In the cold state, this is the state where we know that this data will be fetched or will be queried, but it will be not very actively. So then we will move it to that. It will be less expensive, it will reduce our cost. And then eventually when we know, like, once the data is moved into the cold state, then after like 2 years we no longer need that data, because we the all the analytics and all the things that we use in our system or application is relevant for like 3 years. After that we no longer need that data. Then we can automatically move that data from cold state to delete state. And in the delete state we can have a condition that after the data is in the cold state for like 1 year or 2 year, then move that data to delete state, and in the delete states the data automatically gets deleted. So then this is how the life cycle works, but it is not mandatory that you plan it in that manner. You can have the data in hot state, and directly after that you can delete it. Like, once the data is full you can delete it, or you can have a hot state, then you can move the data to warm state, and then you do not have any cold state. You after warm you directly delete the data. So you can plan this data life cycle according to yourself. So moving forward to the implementation of OpenSearch, how we can set it up using Docker, and how we can use Node.js to perform different operations on OpenSearch. So let's go through the code of OpenSearch. So I have used Docker Compose to run OpenSearch. So I will explain you quickly how the Docker Compose configuration are set up in OpenSearch. So we have basically three services. One is OpenSearch Node 1, in which we have specified the image, that the image should be latest, whatever the latest image is. Then we have the container name, which is also Node 1. Then we have few environment variables, that what is the cluster name, what is the node name, then what are the seed host, and what is the initial cluster manager nodes. And in that we have specified the node 1, node 2, and all this setting. This is basically the boilerplate setting that OpenSearch has provided, that this is the official Docker Compose configuration provided by OpenSearch. So you can check that out. I have the link of this project. This is hosted on GitHub, so I will paste the link, and you can see that, and you can copy paste that configuration as well. We have two OpenSearch nodes, and then we have OpenSearch dashboard service. So what this dashboard does is it visualize everything. You can see all the indexes, that the index is in hot state, it is in warm state, and how many documents, how much data that it is being written to. You can play with your data, you can analyze it, you can install plugins, you can define different policies. So I would recommend, like, use OpenSearch dashboard. Like, it is not mandatory, you can cut that out as well. Like, OpenSearch will still work, but it is a very useful tool. So then we have specified network and volume. So yeah, this is it. So this was basically the Docker configuration. So let me spin up the Docker so that we have the OpenSearch and OpenSearch dashboard up and running. For that, I will type Docker compose up dash D. Dash D basically runs the container in the background, so we do not see all the logs. So if I open the Docker desktop, you can see, like, we have different OpenSearch Node 1, OpenSearch Node 2, and OpenSearch dashboard. It takes like few minutes to spin it up. So in the meanwhile, I can explain the code. So all the code that we have is basically inside the app.js file. It is a very simple Express project using Node.js Express framework. So in that you can see, like, we have the OpenSearch project library npm module. So we use that to perform different operations on OpenSearch. Then we have .env, because the OpenSearch service that we have spin up, it has a self-signed certificate. So we need to have this variable in the env, because if we do not have that, then it will throw errors regarding SSL connection. So that's why you need to add this. Then you will not face any errors regarding SSL handshake. So that's why I have included the .env and added this line. And then this is the require of express basic. And then I have supplied the URL of OpenSearch. And this as you know that the OpenSearch is running on localhost 9200, and then this is the username, this is the password, this is the default username and password. You can specify that in the URL. This is my index name. And then I have created routes for different operation. So the first route is to create an index in OpenSearch. Whenever you have to add the data, first you have to create an index. That this is an index like books, for instance, users, for instance, it can be departments. So there is an index. You create an index, you specify the settings. You can also specify the schema in the index as well, but it is not mandatory. If you do not specify the schema, then whenever you add the document, it automatically creates the schema on its side. But you can also specify schema. So and then you can see like in this I'm specifying the number of shards, number of replicas. So I have set it up to 1 and 1. I won't go into much detail regarding that. uh, it is like basic concepts of shards and replicas that we also have in MongoDB. So then we have this method that indices.create. It basically create an index based on the setting that we have provided, like how much number of replicas that we need for that particular data. In terms of obviously testing, you will set the replica to 1, but in case of production you can set the replicas to 2 or 3, so you will not lose your data. So it is a simple method. It will create your index. So let me go to the browser and open this route. So in this route, if I press, so you can see, wait a second, I have forgot to run my app. So to run the project, I will simply type npm run start, and then I will go to the different routes that I have. So it is telling me that the Express app is listening on port number 3000. And then I go to this URL, localhost 3000 slash create index. I press that, and it basically creates an index for books, and it is telling me that it is status code 200. The index is created. And if I go here and refresh, I can see that the index is created because the Docker container is up and running. So 1 second, I have to remove this. You have to basically go to localhost 5601, then type in admin, cancel that, then go to index management. And index management, you should go to indices. And in the indices, you see like this index is created books. It does not have any documents right now because we have just created that index. If I try to recreate it, it will give me an error that resource already exists, right? Because we already have the index on that particular name. So the next method is to basically add a document inside the index. So this is the document that we are adding. It is a JSON document. We have the title, it is a movie name, then we have the author, we have the year, we have the genre. So we add that document inside the index books, and we simply call the client.index method, and then we uh, return the response body. So let me call this URL, and you can see this index is created. And because we have not specified an ID, so auto generated ID is given. If we specify an ID, then that ID will be given to that particular data. For instance, I specified the ID myself that it is 2, and I changed this data little bit. So then you can see like if I change that, and if I rerun the project, and Or you can start the project with node so you do not have to rerun it. Whenever there's a change, you can just refresh and it will again start the server. And then if I go here, if I add the document, now you see there is not the ID is 2. It is not an auto generated ID. So this is how you can create a document. If you need to specify your own index, you can specify that. If you want auto generated, you can do that as well. I will add one more document as well, just to showcase different documents in the search. So let's add that as well. And then this is also added. So now we will look into how we can search the documents. So we have this route to search the documents. So this is the syntax, like query. We need to match title. Title needs to be the outsider. So this is the title that we have when we're adding the document. So we want to search based on that. Right now, I'm not taking this data from the URL request. Obviously, in the production environment, you will take this data from the front end app and then use it. But right now, I'm just taking the search parameter. It is hard coded just to showcase you how it works. So I go back and go to search route, and you can see, like, because the outsider is present in multiple documents, so that's why all of them are coming. But the good thing is, in OpenSearch, the data is indexed on all the elements. It is not indexed based on just title. All the data that you add in OpenSearch, you can search the data based on any element, any key value. So if I want to search data based on this Stephen King, so I can do that as well. It will also return me the data. So if I come here and if I type Stephen King, and what's the this is author, I change that to author. Okay, and I go back and search, and you see, like, still I get all these documents. Let me add some other document to just to showcase you better. For instance, in the author, I add Josefa. Okay, and then in here I also type HUZ, like partial, my partial name, right? And then I go back, I create the index first, right? And then I come here, I search. It is not showing me. Wait a second. I think I need to provide the full name. Then if I come back, if I search, what? One second. The data is added inside the author. It should return the data based on the name, I believe. But let's see. I believe it will work. So let me go back. Yeah, now you can see you are getting the data that based on author Josefa, this is the document that is available. And so we have checked like how we can search the data. And then we have like different regular expressions that we can also use. And this right now it is like selecting the exact data, but we can also have like different regex in the search operation as well. If I go here, you can see like you can have different regex, different things that we can add based on how we need to search. Like we have different things like dot, question mark, plus, steric, and different things like, and you can make your search even more powerful. So you can use that. So then going back to how we can delete a document, because we have added documents, we need to like delete a document. So how to do that? So for that, what we need to do is, first of all, we need to understand that, for instance, like previously, like this is the document for Josefa, right? So if I go back, I see this is the Josefa document, right? So I need the ID. So if I provide the ID, then by providing the ID, I can delete the document. So in the delete document, I provide this ID, and then I go to the delete document route, and I press that, and it deleted that particular data. So, and then now if I go back and search for it, it will say like no document exists. So this is how you can delete a document, and it is very simple. You just need to provide the index name and the ID, and this ID can be auto generated by OpenSearch, or you can provide that yourself, like, and then whatever the ID is, you need to just provide that ID here and it will delete that document. A very simple client.delete method. Then we have a method to delete the index. So to delete the index, we have this method client.indices.delete. So we just need to provide the index name and it will delete that index as a whole. Just before deleting the index, let me show you in the OpenSearch dashboard so that you know how it works. Like you see, like this is the books index and it has like three documents right now. One of them is right now deleted. And if I go to books, I can see more details like what is the total size, stuff, number of replicas, and the mapping. Mapping is basically the schema. So we have this author is text, we have title, year, and stuff like that. So we can also check the data from here. And then we also have a dev tool. So the dev tool can be used to also search data, add data, and stuff like that. So for instance, we use this dev tool to query the data in books index. So you can see like all this data uh, coming. And then if you need to add new documents, you can also do that by having command post books slash underscore docs. To get the data, it is books slash underscore search. So you can also check out this, like this dev tools is also very powerful. You can add data, search data, do a lot of things, create policies. So if I add this, and you will see this data is added, then now if I search, I have this thing added here. So yeah, this is how you use it. This dev tool is basically right here in the management dev tools. You can see that here, and you just need to click on this and then click on play button. It will run this command. And then about the index, you need to in the side menu, you need to go to index management and go to indices, and you can see all the indexes. So this is like a very basic use, like how to establish a connection, how to create an index, how to add document to an index, and how to delete documents, delete index, and stuff like that. Let me run the last command to delete index. It will delete the if I go back and refresh, you can see the books index is gone, and whatever data that I have in this index, it is also deleted. Now to showcase you like more other features of that as well, I have a staging instance in which we are using that for another application that I am developing. So we recently migrated from Elasticsearch to OpenSearch. So we are running different POCs to get data from Elasticsearch to OpenSearch. So that's why I have a lot of data in this. And you can see like I have messages. This is the legacy messages index, means that this is the old messages that we have imported, and the legacy conversation, legacy contact. You need, if you open that, you can see like the mapping and stuff. And we have different data type because this is the actual system, so we have specified the data type accordingly. And just to showcase you, like, it is not only index, we also are using templates. We have created templates like for instance, like if a new index is created and the index name starts from message status stash dash, whatever the name is, it will have the settings of this template. So in the template we specify the schema, we and then whatever, and we specify an index pattern. So all the, if a new index matches that pattern, then this schema, this configuration is applied on that. So this is templates. And we have alias. I don't think we need to go in detail regarding that. Then we have the policy. As I was showing you in the slides, that the data stays in hot state, then it goes to warm, then it is deleted. So we have also created a policy. So for this policy, we have specified that it will work for these index patterns, that if the index name is matched in this regex, in these different regex, then this policy will be applied. In this policy we have the initial hot state, and then the data stays in it. After some limitations, the data is moved over to the delay state. Delay state is basically the warm state, in which the data is no longer inserted to on that index, but the data is basically stays there so that we can search the data from it. This is the delay state, and then after 1 year this data goes to delete state, and this data is deleted. So this is it. Like, if you want to view JSON, you can see this whole policy, how the data is moving between states. We have transitions. So it will be very long video if I go into detail how I did that, and how I actually migrated from Elasticsearch to OpenSearch. So I will do that in some other videos, more advanced video of OpenSearch. And then we have like indices and policy managed indices. Managed indices basically means that the indexes that are managed by the policy, that means that their state will change with passage of time. That the policy that you have created on these indexes, the policy will be applied, that after some time they are moved to delay state or delete state. So all the indexes which are not which does not match the index pattern that we have created will not show in this particular policy managed by indexes. And then you can see snapshots and stuff. If you create snapshots and stuff, then you will see that in here, how to create your snapshot, like a snapshot of different sources and stuff. So this is also to like take a backup of the data. Like you can see, like, I have different snapshots at different times. So you can like restore them, and it automatically basically takes the snapshot of the data. So, and to showcase you the dev tools, like you see, like I have different requests I have created to create documents. Like, for instance, conversation, I'm creating data. It is data is being created. If I go to search, the data can be searched and stuff. And this is to create a template, index template. This command is to basically create an index template. Then I have this policy. You can also create a policy using this command, and you can use this command from, you can run this from Axios as well to create your own policy. Whatever JSON that I have get, that I was showing you in here, uh, like you can create a policy from the visual editor. You can create stages, you can create stuff, and then you can get the JSON value, and you can use that, and you can create the index policy from your code by running an Axio put request. And then you see, like, this is basically how it is. So thank you so much, guys, for watching the video. And if you want to see more videos on open source, then comment below. Thank you.